Yep.
Yep. Mr. Joshua, do I have permission to start or should
Please
we
do.
wait? Okay. So I've practically called everybody's name that is online. So I'd like to say an official good evening and welcome to our CyberUp series. This is version 6.0. And okay, my name is Sam. Yeah, it's written there, but though. So this is one of those sessions where we get to pick a tool or a process in cybersecurity and just try to brush on our skills or learn a new thing in order to develop ourselves technically. So today we'll be talking we'll be with Mr. Dan. That's our but I'll come back to introducing him though. But today we'll be talking on understanding injection vulnerabilities, like a whole lot in stock, I'm very sure. So taking us on the ride is Mr. Daniel Olaolorun. Yeah, Mr. Dan. So Mr. Dan is actually a student of Obafemi Awolowo University. Now, one amazing thing about him is he's actually studying law at the moment, and then he has his head deep into information security also at the same time. And yeah, he's done internship with about different intern. Like he has the experience. I want to call him our boss for tonight. So I'd be handing over the mic to him to take us through this amazing journey. So sit back and learn one or two things. Mr. Dan, over to you.
Thank you very much, Mr. Sam.
Yeah.
Uh, this evening, would we will try to explore injection vulnerabilities in the entirety. Really, injection vulnerabilities are a broad classification of web vulnerabilities that stem from unvalidated or unsanitized user input that are imputed into a web application by a user. So generally, when developers write code, they just assume that whoever is using their web application is a good user. Let me put it in that sense, and they allow their code to accept input, any kind of input. Those kind of inputs can be altered, can be used to alter the process of the web application. When such process is altered, the result is an injection vulnerability. Injection flaws primarily they allow a malicious attacker to relay unwanted code or instruction through a web application to alter the normal workings of the web application. Now I'll break this down. There are a number of injection vulnerabilities that we have, a multitude of them. To know how severe injection vulnerabilities are, injection vulnerabilities is number one kind of vulnerability that's listed by OWASP. I don't know if anyone is up to date with the OWASP standard. That's the Open Web Security Standard, generally used all over the world. So, injection vulnerabilities are one of the most common and most dangerous attack vectors in web application security. Depending on the kind of vulnerability that might stem from injection, the injection vector, it might result in execution of code, injection of database queries, even injection of operating system commands. Tonight, we are going to be talking basically on three kinds of injection vulnerabilities. We are going to be talking about command injection, we are going to be talking about SQL injection, and we are also going to be talking about cross-site scripting attacks. These are one of the most common types of injection vulnerabilities that we have on websites today. Injection attacks can stem from, just like I said earlier, the input of unsanitized data into the web application. Arbitrary commands can be, I would like to give an example so that we'll get a sense of what we are talking about today. I would like us to start by exploring command injections. Now, command injections, what are command injections? Command injections, or operating system command injections are simply injection attacks that allow the execution of arbitrary operating system commands into the web application from an input form. This might be maybe a login page to allow a user authenticate into the web application, might allow operating OS command injection. I'm going to show a code sample to give us a sense of what this would look like. So I don't know if everyone can see this.
Yes, yes, it's quite visible.
Okay. One moment. Now I would like to break this down. This is a PHP code sample from a web application. The code is basically taking input. That's the command, the get string that we can see here. It's taking input and passing it to a variable, the command string variable. And this variable is then passed into an operating system command. That's the pass-through. If you work with PHP, you understand that the pass-through command is basically executing underlying operating system command. So any string that is imputed into this command, once the code execution gets the pass-through point, it executes it directly on the operating system and passes the result back to the user. Now, command injection generally has two types. There's active command injection and blind command injection. The difference between active and blind command injection generally is that active command injection, when it is exploited in a web application, you can generally see the result on the web page instantly by whoever is exploiting the web application. Exploiting a command injection vulnerability can result in so many malicious actions and results, bad results, which we don't want on a server. For example, it might result in full compromise. It might result in remote code execution. Remote code execution is like the ultimate kind of vulnerability that we can have. It means that the underlying server is ultimately compromised in that way. Now, talking about back to command injection, we have two basic kinds of command injection. We have active command injection and blind command injection. Like I said, active command injection, when it's exploited, you can see the results on the underlying page. Now, to visualize this, we would use a lab. We are going to be using TryAcme, a TryAcme lab. To see how this might work out. Injection vulnerabilities are actually a lot more popular than most people would imagine, because any places where one can impute any place in the web application that allows user input is already a vector for an injection attack, and most especially either a operating system command injection, a SQL injection attack, or a Crosssite Scripting attack. Command injection attacks generally stem from the execution of arbitrary OS commands in the web application. OS command, if you know Bash scripting well, these are command injections on a Linux operating system. You can run commands that would allow you, that will enable you to get remote command execution. Now, right now, we're waiting for our lab to load so that we can visit the IP address and see what it looks like. So I think we deployed our lab already. So just go directly to the exploitation of the command injection sample. Sorry, it looks like this is taking a while to load. Okay. Okay, now we're here. Okay, this is a sample. This is a web page we're looking at right now. And here we have the option of searching. It's a sample of an input space in the web application. So a command injection, like I said, are divided into two types. For example, how do we exploit an active command injection where we can see the response directly on the web page? Here to test for a active OS command injection, we might attempt to enter arbitrary operating system Linux commands like list, for example, like ls. Everyone knows what ls does in Linux. So as we enter that directly, we can see that immediately we're getting a response to see where at what point the web server is 7. You see where in the web server we see what the web server is serving right now currently. We can see about 4 different files and a directory. This is an active sample of the OS command injection vulnerability. On this page, we have the operating system command vulnerability, injection vulnerability. Sorry. So to exploit a vulnerability such as this, one might be able to get remote code execution. The remote code execution, like I said, is the height of it. So honestly, getting a OS command injection is as good as exploiting the server in its totality, because honestly, once you get OS, or you can execute commands directly on the underlying server, the server is as good as compromised. I would also like to go directly and say, when you're about to exploit the OS command injection, there are certain types of commands you might want to input in order to enumerate the server, such as who am I, to know what command, to know who you're running at as on the servers, for example, or know you can even port scan the server through once you can execute code directly on the server. It's as good as compromised. Going directly to the blank OS command injection. Say, for example, you are attempting to enumerate this page in order to test for a command injection. If you're attempting to run the basic command "who am I" on this page, we can see that based on what code is running here, it doesn't look like this is exploitable. Although the code we are looking at directly is actually exploitable for a blind OS command injection, although we don't get a visible response by just looking at the screen. Please, I would like whoever has the microphone on to please put it off, because it's hard to. So, as we can see, we are attempting to run the OMI command, Linux command on this server, but we are seeing that it doesn't look like this. Please, can the person whose mic is on put that off? It's hard to. Yes, thank you. So attempting to run the OMI command it's showing an error, which might seem like this is not exploitable, or we might not be looking at the vulnerability. But reading through the source code, which is this, one moment, we can see what's going on behind the server right now. We are taking the username parameter into a variable, into the username variable. We are concatenating that into a command string. Now we're passing that command back into an exec function in PHP, which is executing an underlying OS command, basically. And the code is also checking if the after evaluating the code, if it returns an empty user, the code will alert danger. If it finds something, if it finds a valid user, we're supposed to input a user into the variable. Hello? We're supposed to input the user into the variable, and if the alk command checks through the etc password file and looks for a valid username, if it finds the username that we inputted into the code, it will execute this function and pass it back as a result back to us, the user. If it doesn't, it's going to alert us or give us an error message which we can see. Now we are seeing that we're actually executing a OS command here, and this is the best avenue to actually exploit a blind command injection, because this command string we're looking at can actually be exploited, because we are taking a user imputed variable. We're taking user input that can be manipulated in order to exploit this command we're looking at right here. Now, how can this be exploited? This can actually be exploited in a variety of ways. For example, this can be used to enumerate the internal network. For example, we might not be able to get a response right now we get a visible response, but we can construct the code in such a way that it will be able to send the response to a remote server. Or, for example, an easier way to do it is to ask the page to ping for a certain amount of seconds in order for us to be able to dictate if it's executing our command, since we can't get the direct feedback on the page right now. For example, we can use the ping command to ask the page to maybe to ping for 10 minutes. If you see it loading for 10 seconds, sorry. If we see it loading for 10 seconds, we are able to time it. We understand that the code is actually running, and we know that such a vulnerability exists on the underlying database that we can exploit. Or we can send such. This is hosted on a local network, so it's hard to send this to a remote server right now. Now we would move to the next vulnerability we'll be talking about this evening. For whoever asks questions, there'll be avenue to answer questions at the end of all this. So we'll move to SQL injections. What is SQL injection? SQL injection basically is the authentication of SQL query. Normally, when developers write code, they write certain queries with placeholders for values that allow, for example, you want to authenticate into a web application. It asks for your username and your password. It takes your username and your passwords, and it queries the database to know if such username and password exists on the database. Once it checks the database and it sees that it exists, it will send you a response back and authenticate you into the web application. Now, for example, let's say the variables, your username and password, is concatenated directly into the SQL query. For example, this is a code sample in which the the variables, the username and password variables are concatenated directly into the SQL query string. Now, this is a nice recipe for an SQL injection vulnerability. And now, how can this be exploited, and what would be the result of the exploitation of an SQL injection? Now, SQL injection is one of the most damaging kinds of injection vulnerabilities that exist in web applications today. Now, why do I say that? SQL injection can lead to the full compromise of the underlying web application's database. How will this work? Say, for example, the easiest idea about this would be authentication bypass. When I say authentication bypass, it means that now this code snippet we are looking at, if this exists in the web application, this might be used to bypass, say, for example, an admin account. How would this work? We are taking in a variable, the password variable and the ID variable, and we are concatenating that directly into the SQL query. This is the SQL query. It says update account, set password, where password, set password equals password, the password variable, where account ID is equals to ID that we're taking in directly. Now, if a malicious user decides to alter the ID parameter, for example, and puts ID, and if you understand SQL, structural query language, you understand that in the syntax, there are options for comments and all that. Now, take this for example, this string. If someone attempts to authenticate into this web application as an admin with this code snippet, say for example, a person puts empty password and in the username or ID field, you put admin with 2 dashes after, enclosed in brackets. That can be used to bypass the authentication mechanism entirely. Because, for example, the SQL says update account, set password, where password is equals to password variable, is equals password, and where account ID is equals to ID. If person decides to put the account ID put admin as the account ID and put these last characters in it, the person can essentially comment out the query for the password. Now let's see this in action. We'll go back to our lab and watch this being exploited. So essentially, right now, we're looking at the login page where the page accepts a profile ID and a password in order to authenticate the user into the web application. Yeah, the underlying code is probably the underlying SQL code is this. So if we attempt to authenticate into the web application with say a normal username and password, say admin and password. We can check. It says the account information you provided does not exist. Yeah, we can, below the web page, we can see the query that's executing on the underlying database. It says select username, name, profile ID, salary, passport, email, nickname, password from user table where profile ID is equals to admin and password is equals to the password we attempted to authenticate with. Now, say for example, if we attempt to put one is equals to one with the dash, this dash behind it represents the comment string. We're essentially commenting out the password. We're essentially commenting out this part of the query out of the equation, which means that when we attempt to log into the web application, it authenticates us without actually checking if there's a user with this name in the web application. Now, why does this happen? Essentially, one or one is equals to one is true. Now, the web application is checking for a true condition in order to authenticate the user into the web application. It's checking the web application if someone actually exists. But when it attempts to evaluate this part of the query, it evaluates to a true, which means that the web application, the SQL language allow the web application authenticate anyone, the first available person it can find in the web application. Sorry, one moment. Okay, yeah, in this web application we are looking at, the most essential thing to note is the last three characters at the back. Essentially, what this is doing is commenting out the last part of the query string out, which means that the query is not even evaluating the last part of this query, it's not evaluating if a password exists or if you should check for a password at all. We might just because this is the web page is actually evaluating if we are inputting a password on the server side. It would matter that we need to input something at least into the web application, although it won't check on the server side. It won't check if the password string exists, because essentially we've commented that part out of the query string. Sorry. Now we're getting error messages because different kind of databases, they have different ways of evaluating comments. Now, MySQL database has a specific type of evaluating what a comment would look like. So right now, I don't know what database is we are currently working with, but this is a basic SQL injection. So a basic SQL payload would work for it. Now we have certain places we can go to look for SQL payloads to use to test for web application. For example, my favorite is going to payload all the things. It's a GitHub page where you can check for different kind of payloads. Let's go. Yeah, we can see sample payloads that we can use to test for SQL injections in our web application. For example, just attempting to uh, we're getting some error messages. Now, SQL injection might take a lot of trial and error, like we're getting right now, because the uh, different payloads, you might require exploring different payloads in order to get the injection point, to get where it's vulnerable. Right now, we don't have the correct payload to exploit this page right now. So we have to try multiple payloads in order for it to work. It might seem that we are not working with MySQL injection. We are not working with MySQL database right now. It might require another kind of payload. The payloads I was attempting to use right now were based on MySQL, MySQL databases. I'm going to relay the room and we'll come back to that lab later on. I'd like us to move to our third vulnerability for the evening, which is cross-site scripting attacks. Now, what are cross-site scripting attacks? Cross-site scripting attacks basically are kind of client-side attacks. Now, client-side attacks generally are attacks that are exploited on the client side, for example, on the web browser instead of on the server side, like the two other vulnerabilities we've talked about. SQL injection and OS command injection are basically exploiting the web server, underlying web server, or the underlying database of the web application. Now, in a cross-site scripting attack, you're basically executing malicious code in the end user's browser. Now, what does this mean? Basically, in a cross-site scripting attack, you're inputting on a web form. A cross-site scripting vulnerability might arise when a user is allowed to input code, and such code is not filtered or validated before showing it back to the end user. Cross-site scripting attacks are kind of client-side attack that allow execution of JavaScript code in the user's browser by way of unsensitized user input. When this unsensitized input can be executed as code in the end user's browser, this is known as a cross-site scripting vulnerability. Normally, cross-site scripting vulnerabilities allow the execution of client-side code, mostly JavaScript code, in the end user's browser. One is where you can anywhere where you can input arbitrary characters in the web application. A cross-site scripting attack might arise once such code can be executed back to the end user. We can check out the lab here to get the feel of what the cross-site scripting attack might look like. Generally, we have two types of cross-site scripting attacks. We have stored cross-site scripting attacks and reflected cross-site scripting attacks. Now, what's the difference between the two? A stored cross-site scripting attack generally is stored on the server. Say, for example, when you try to exploit a cross-site scripting vulnerability, when you input your code that you expect to get executed on the server, you input it in the web form. Instead of such information or such data is stored in the database of the web application, and whoever visits that vulnerable web page that you just imputed malicious code, such code that you imputed will be executed to the end user, to the victim, whoever it is that visits such page. Now let's see such vulnerability in action. Now, okay, before we even explore what the cross-site scripting attack might look like, what kind of damages can result from a cross-site scripting attack. Now, just like all injection attacks, it's a very dangerous kind of injection attack, which means that even though it's a client-side attack, it might also result in full compromise of the database. It might result in, with a cross-site scripting attack, it's pretty easy for a person to exploit for example, retrieve the admin's cookie in order to authenticate into the web server directly without even knowing the username or password of the administrator of such websites. Now let's watch the lab and see what a cross-site scripting execution of client-side code might look like. I would go ahead and create a sample account in order to test this. Now we are looking at the web page, which has the option of you imputing a comment into the page. Now to look for, we can go back to payload auditings. Like I said, it's a very good place to look for payloads for exploiting web vulnerabilities. They have a wide range of options for any kind of vulnerability you might look for. So I'm just going to pick a basic payload in order to show what this might look like. Now, basically, we're looking at the JavaScript code. This one line of code. What this is basically saying, we're in a script code block, and we are telling the code to run to alert us. Now, if we run this code and impute it, we see that we get a pop-up that says XSS, just like we inputted into code. Right now, we can see that our code executed. In the comment section where our comment is supposed to appear, we cannot see anything. That's because our input into the web application is already stored as code, and anybody that tries to reload the page would be executing our code. Now we can see that if you try to reload the page, our code is getting executed. Now, this is a good example of a stored cross-site scripting vulnerability. Now we can move on to a reflected vulnerability. Now, what's the difference between reflected vulnerability and a stored reflected cross-site scripting vulnerability and stored cross-site scripting vulnerability? In reflected cross-site scripting vulnerability, the code, instead of being stored on the server, on the database of the server, and being reflected to whoever is opening the page or reloading the page, in a reflected cross-site scripting attack, the payload is only executing in the context of whoever is running the code. Now we can watch, for example, instead of attempting to reload the page, just like in a stored site scripting attack, if we try to impute anything in this form, it will execute initially for whoever is attempting to run this code. Now, this kind of vulnerability is still dangerous in the sense that even though it might not sound so easy for you to make someone click a link in order to execute code in their browser, such a kind of exploitation is not so complicated, because all it takes is just sending someone a link for them to click on with the payload embedded in such a link, and such code will be executed in the context of that person's browser. Now, what can arise from executing code in someone's browser? It might seem like it's not such of a dangerous vulnerability because it's not executing on a server, but stealing the admin's cookie is all it takes in order to compromise a web application. For example, if we decide to retrieve the admin's cookie, we can send him a link and ask him to click. Now, this link might pop up the person's cookie and send to a remote server. I'm going to look for a payload that can do that, and would attempt that right now. Okay, now we have a code sample. Right now we are looking at the code sample that can extract a remote user's cookie and send to a remote server, arbitrary remote server controlled by the attacker. If we run this code in the context of a user, and if we embed this code in the context of a user and send it to someone arbitrarily to click, once the person clicks on it, this code block will retrieve the person's cookie and send to the specified remote server, like we said. Say, for example, just running this would pop up the cookie embedded in the web application. Now we can see, and this is a basic attack, but obviously this can be changed with other kind of attack in order to gain higher privileges in the web application and so on and so forth. So now that we understand that injection attacks generally stem from unvalidated user input, we can see that all attempts to exploit all kind of injection attacks stemmed from imputing something into the web application. Now, how can we prevent this? How can we protect our web application from being exploited, since user inputs cannot be trusted in the web application? I think the first option might be to ensure the standardization of input in all web applications. Every place that a user can input content into should be sanitized. Now, what do I mean by sanitization? Sanitization basically means the stripping of invalid characters or malicious characters from the web application and preventing such characters from getting to the server. Now, you can do this kind of validations client-side and do it with JavaScript when you're writing your web application. But essentially, that might not work because it might be easily bypassed, because if you proxy your connection through Bob Suite, for example, you can exploit that part and not necessarily have to deal with client-side validation of user input. So I would actually recommend that validating user input should actually be done. It might be done client-side and both on the client side and both on the server side. That is both on the web application and before any type of code is executed on the underlying server. Now, let's pick each of the vulnerabilities and exploit and break it down. For example, on operating system commands. Now, in what places do OS command injection appear? For example, this as an example, initially we exploited OS command injection here. How can this be prevented? Now, stripping all kind of, for example, we're running a Linux command operating system for this web server. Strip all kinds of commands should be stripped before sending to the database to prevent execution of arbitrary commands on this web application. If we move to SQL injections, SQL injections is actually one of the easiest vulnerabilities to actually prevent against, because in most programming languages that are used to write web applications, they already provide libraries. They already provide libraries that abstract all this hard work away. These libraries generally validate user inputs, strip out malicious characters from the web applications, and prevent input of malicious characters into web applications. So it basically prevents any kind of exploitation of SQL injection in your web application. Also, one should also prevent the concatenation the concatenation of user input directly into any query string. Say, for example, you're writing a web application and you want to maybe you query the web application, you query the underlying database of the web application, and you want to show the user maybe his name. You shouldn't say, for example, take the user ID directly and try to impute that back into the page that you are showing. For example, if you're writing a web application, once you take in user input, you have a library to strip out every kind of character and make sure that it's only allow characters that are allowed to the underlying database, and those characters should be characters that are benign, that are not commands, not something that might be easily exploitable. In SQL, for example, there's something called PPS statement. PPS statement generally is like an abstraction. For example, it's like placeholders for SQL queries. And PPS statements are supposed to prevent SQL injection from happening primarily. They're like placeholders for the password, for example, here, the password ID and the account ID variables. They are placeholders, so you cannot concatenate user input directly into the SQL query, which means that SQL injection is impossible to exploit in such a situation. Also, regular code reviews are essential in preventing injection vulnerabilities. When you're writing web applications, you do regular code reviews, you do automated vulnerability testing. Now, there are a couple of tools for you to check your web application with and prevent injection attacks. Now, my favorites, for example, for command injection is called Core Mix. You can find this on GitHub. If you run your web application through it, you might be able to test your web application for command injections. Now, there's another popular tool for SQL injection attacks called SQL Map. This is, you can also check it out on GitHub or on their official website. Learning basics. Now, using SQL Map might even allow someone who doesn't understand structural query language to exploit a web application. So it might be advisable for a developer to actually run his website through the tool in order to look for loopholes and see where SQL injection attacks might actually appear in such web application and patch them up before an attacker can exploit such. For cross-site scripting attacks, primarily, just like all those vulnerabilities are stemmed from unfiltered user input into web applications. Primarily, it just takes validating user input in order to prevent cross-site scripting attacks. Thank you very much.
All right. Thank you so much, Mr. Daniel. That's wonderful exploration, yeah, of the injection vulnerabilities. Mr. Sam, are you online? So if you have any questions, I think you can raise your hand up so that we could take some few questions before we go. So I hand over to Mr. Samuel. But Mr.
Yes.
Dan, you can turn off your screen so that we can take a snapshot. Yes. All right. Please, if you have any questions, you can raise
Yeah,
your
you
hands.
can just raise up your hand, so you'll be given the opportunity to speak. Like any question, any addition. Is there any? Okay, as if there's none. Mr. Dan would like to say a very, very big thank you for taking out time to walk us through injection. Actually, like it's quite an important topic. Like when you're dealing with web application security most at times, because like so far the that's the OAPS like you mentioned, that's the Open Web Application Security Project. So far, like their predictions, or should I say vulnerabilities, for a long time now, injection has been A1, like on top for a while now. Like, and there's a reason to that. They keep shouting, do this, do that. But the issue we have is most persons just they are concerned about just deploying web application online without security. Like they don't really pay close attention to security. And I guess it's our work to let them know. Most of these things you tried out now, one could just Google any website and you'll be surprised you see they are vulnerable to most of these attacks. So would like to say I don't think there's a question. So um I don't know. Okay, there's no question. Nobody's raising up his or her hand. So we'd like to say a big thank you to you. Um, Mr. Dan is actually, like I said, I don't know for those that are not online when we started, he's a lawyer, like our cyber lawyer taking us on something as technical as this. So like me, I feel challenged personally. I feel challenged. So I'd like to say a big thank you on behalf of the team and the whole community members. So I don't know if there's any question after now, and it needs to get. We would probably pass it across to you, just in case. And I don't know. We'll drop your LinkedIn. That's the link to your LinkedIn profile on the group chat also, in case anybody wants to connect with you. So I think that will be all for tonight. Joshua, any other thing?
Not at all. Man,
Or
thank you so much, everybody, for joining. So this will be uploaded to our YouTube channel probably by tomorrow, so that you can rewatch.
Thank you very much for having me.
all right, thank you. And for others online, I can see Adigoke, I can see Mr. Ede, I can see Emmanuel, I can see Mr. Faith, I can see AY, I can see our honorable CTO that doesn't want to say anything all this while. I can see Joshua Yekule, I can see Lee Ward Stanley, I guess. I can see Stephen Bitrus. I can see Mr. Oguniro Ibrahim. So we want to say a very big thank you for coming. And if you have any topic you'd like to take us on, like this is one of the series, like one of the thing we started with the community just to help ourselves, get used to most of these tools and processes in cybersecurity. So if you have any that you think you can take us on or walk us through, you can reach out to me or Mr. Moses Joshua, and we'll set up one of these. So we want to say a big thank you to everyone for joining in. I think that will be all for tonight. So do have a lovely evening. Thank you, Mr. Dan.
Thank you very much. You
All
have a
right,
lovely
bye.
evening too.
Same here. Good night, sir.
Good night.